Hello, physical science students, and welcome to our video about music. We are going to look at what the difference is between music and noise. There really is a difference. We're going to look at natural frequencies and resonance, what those terms mean. And when we're talking about music, we're going to look at sound quality and overtones. What do those words mean? And also, we're going to discuss how different instruments produce sound. So, to some, music might sound like noise, but there is a very big difference between noise and music. Music is a collection of sounds that are deliberately used in a regular pattern. Noise is not. There is no regular pattern in sound waves that make up noise. You can see that right here. There's no pattern. But here, music, no matter what kind of music, the sound waves that make up music have deliberate patterns. So when we talk about music, we definitely talk about musical instruments. And musical instruments produce different combinations of frequencies that determine how that particular musical instrument sounds. When we talk about natural frequencies, we are talking about the frequency at which a particular material or object naturally vibrates. Musical instruments employ natural frequencies of various objects like strings to control the pitch. So when a guitar string is plucked, the pitch that your ear hears depends on that string's natural frequency. Each string on the guitar has a different set of natural frequencies. Resonance, remember, occurs when a material or an object is made to vibrate at its natural frequencies. And it does that by absorbing energy from something that is also vibrating at those frequencies. The vibration of a person's lips in a brass instrument or the reed in a wind instrument cause the air inside that instrument to absorb energy and vibrate at its natural frequencies. That vibrating air makes the instrument sound louder, and that is due to resonance. So why do different instruments sound different, even if they're playing the exact same note? A flute and a trumpet, for example, or a violin, they might be playing the exact same note, the same pitch, even the same loudness, and they sound different. Why is that? We're going to talk about that. That is called the sound quality. The sound quality describes differences between sounds of the identically same pitch and loudness, but their sound quality is different. It is a result of overtones. What are overtones? An overtone is a vibration whose frequency is a multiple of the fundamental frequency. So a whole bunch of words. What does all that mumbo jumbo mean? Let me explain that. You might think that a musical instrument vibrates at only one frequency when you play only one note on that instrument. But actually, musical instruments vibrate at many different frequencies. When you're playing a note. Even when you just play one single note, there are many frequencies that are vibrating. The very lowest of the frequencies is called the fundamental frequency. If we look at a guitar, for example, a guitar string, the fundamental frequency is produced by the entire string vibrating back and forth. And here's an example of that fundamental frequency. It primarily determines the pitch of the note that you hear. The other frequencies, here is another one, and another one, they are called overtones. We have the fundamental frequency, then the first overtone, which is a different frequency, the second and the third overtone. It's basically a vibration whose frequency is a multiple of the fundamental frequency. This is a multiple of the fundamental frequency. You can see it's like 2 times. That's why it's the second harmonic. This is 3 times exactly. So it's called the second overtone or the third harmonic. This one you can see is being reproduced 4 times. It's called the third overtone or the fourth harmonic. Overtones determine the sound quality of the note you hear. If you think about that example of a trumpet versus a flute being played. If both players are playing the same note. They are producing the same fundamental frequency on both of those instruments. However, the loudness of each of those different overtones varies between the two instruments. These different overtones will have, although they are playing the same fundamental frequency, the overtones will be louder or softer for the different overtones, and that gives them a very different sound quality for that note. So a musical instrument is any device used to produce a musical sound. And there is an incredibly diverse amount of different kinds of musical instruments throughout the world with all the different cultures. There are many, 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 many different musical instruments. We're going to just look at a few different categories of musical instruments. One would be strings. And compared to the overall history of musical instruments, strings instruments are actually quite modern. The first manufactured string instruments probably did not appear until maybe 6,000 years ago. Today, you might hear violins or electric guitars or harps. And in string instruments, sound is produced by plucking, striking, or drawing a bow across a tightly stretched string. Here's an example of a violin being played. The sound of a vibrating string, however, is very, very soft. So most string instruments include a way to amplify the sound. And in the case of the violin, this is called a resonator. A resonator is a hollow chamber filled with air that amplifies the sound when the air inside of it vibrates. Electric guitars use what's called pickups, and pickups convert the sound from the strings in that electric guitar into electric signals, which are then amplified before being converted back into sound. So let's look at some other musical instruments, the wind and brass instruments. The largest wind instrument today is the pipe organ. In all wind and brass instruments, however, sound is produced by air vibrating. All brass and wind instruments use different methods to make air vibrate inside the instrument. For example, a flute player blows, here's a flute here, blows a stream of air over the edge of the flute's mouth hole, and that causes the air inside the flute to vibrate. For a saxophone, that's a reed instrument, the player blows across that reed, causing it to vibrate, and then the vibrating reed causes the air inside the instrument to vibrate. For a brass instrument, like a trumpet, the musician vibrates his or her lips to make the air inside the instrument vibrate. In brass and wind instruments, the length of the vibrating tube of air determines the pitch of the sound produced. So in flutes and trumpets, the musician will change the length of the resonator by opening and closing finger holes or valves. In a trombone, the tubing slides in and out to become shorter or longer, and therefore changing the length of the vibrating tube of air to determine the pitch. Let's look at one more category of musical instruments, percussion instruments. Percussion instruments are probably the oldest of all instruments other than the human voice. They produce sound when they are struck, shaken, rubbed, or brushed. Some percussion instruments, such as these right here, have a membrane stretched over a resonator. When the drummer strikes this membrane, the membrane vibrates and causes the air inside the resonator to vibrate. The resonator amplifies the sound. Remember, that's what resonators do. And then you can hear the sound of this drum better. Some drums have a fixed pitch, but others have a pitch that can be changed by tightening or loosening this membrane. Here's a picture of Caribbean steel drums. They were developed in the 1940s in Trinidad. As many as 32 different striking surfaces hammered from the ends of 55-gallon oil barrels create different pitches of sound. The side of that steel drum acts as the resonator. Here is a xylophone. That is another type of percussion instrument. It has a series of wooden bars, each with its own tube-shaped resonator. The musician strikes the bars with mallets that will affect the sound quality. Hard mallets make a crisp sound. Softer rubber mallets make a more muted sound. Other types of percussion instruments could be cymbals, rattles, or even old washboards. One more phenomenon we're going to discuss when it comes to music, and that is something called beats. Have you ever heard two violins trying to play the same note, but instead you hear kind of a pulsing variation in loudness? That variation in loudness is called beats, and it can be very unpleasant to listen to. That would be, let's say one of the violins is playing the note and the other violin is trying to play the exact same note, but in fact they are a little bit off, and so the compressions and rarefactions, when those are overlapping each other here, they would end up canceling each other out. But when the compressions overlap the compressions, that loudness increases. So if two waves of different frequencies interfere, a new wave is produced, and these would just be two that are overlapping. And the new wave would have its own different frequency, and that frequency of this wave is the difference between the frequencies of the two component waves. The frequency of the beats that you hear, this would be the beat period, but the frequency of that would decrease as the two waves become closer together in frequency. So if indeed these two waves would be identically the same in frequency, you would not have a beat that would be heard. Keep in mind that sound waves are compressional or longitudinal waves. This diagram is showing a transverse wave, just thinking about the vibrations on a string instrument. But the sound waves themselves are compressional or longitudinal. It was just easier to visualize maybe what is going on using this transverse wave. Advanced ideas. Lots of advanced ideas. If you have a question or anything interesting that you would like to contribute or look into more about musical instruments, about sound, please ask the questions and look into those. Here are just some different ideas for you to start with, but I would encourage you to ask your own questions and do a little research, and I look forward to seeing you in class.